In this visualization, Earth's magnetic field structure is represented by lines that correspond to the paths charged particles would travel close to the Earth. The Sun's magnetic field, carried in the plasma of the solar wind, flows continuously by the Earth, distorting the planet's field and pulling it back into a windsock-type structure. The red illustrates the higher density plasma which forms the magnetopause, the boundary between the magnetic influence of the Sun and the Earth. The wind also forms a lower density magnetotail behind the Earth, represented by blue in this computer model. This process is happening all the time as the solar wind is constantly flowing by the Earth. But a coronal mass ejection, or CME, can change things. The higher density plasma and stronger magnetic field carried within the CME strikes Earth's field and significantly alters the structure. Here we see the dramatic changes in Earth's magnetic field and the shape of the magnetopause as the CME passes Earth. But close to Earth, the magnetic field is largely unchanged. Earth is protected from the intense solar event. This is the case for a rather ordinary CME. In this example, a CME launched by an X3 flare from December 2006. But what would happen in the case of a more intense event, such as the Carrington event of 1859? With the aid of similar computer models as before, we can explore some of these possibilities. Here, a much stronger CME compresses the magnetic field between the Sun and Earth and generates more density in the bow shock, represented by darker red. The front of the magnetopause is pushed much closer to the Earth than usual. Even the field and plasma trailing behind the Earth are more strongly distorted.